continue with the multiplication. Instead of multiplying monomials times monomials, we are now going to have a monomial times a binomial. So we're going to use the distributive property. We're going to take this x. That's not a very good line. We're going to take this x and we're going to distribute it into each of the pieces. We're going to distribute that x times the first term and x times the second term. And that's how we distribute it. Now, we see solution 1 and solution 2. You will rarely see in high school or any math book in your high school show it in this way, but it's very much like when we have 12 times 8. We distribute that 8 to each of the pieces. 8 times 2 is 16. 8 times 1 plus 1 is 9. So we're distributing that 8. We're going to distribute it just the same way. So that's what they're going to sort of show you. But at the moment, we're going to distribute this term into each of these two. So we have 3 times x plus 3 times negative 2. Very important. That negative is attached to the 2. That negative better be attached to the 2. We are distributing a positive 3, so we better see a positive in front of the 3. That negative does not go in front of that 3. We would not write 3x minus 3 times 2. We would not write 3 times x minus 3 times 2. You will see that in books. That is a horrible thing because we are not distributing a negative 3. We are distributing a positive 3. So notational, that is a horrible way to write it. We're going to write it this way, and 3 times x. Now we're into our multiplying monomials again. 3 times x is 3x. 3 times negative 2 is negative 6. Negative 2 times x minus 2 times 3 provides negative 2x minus 6. We can't combine these because they are unlike terms, so that is simplified. We're going to distribute a c to both of the terms, and it looks like this in our notation. C times c is c squared. C times negative 4 is negative 4c. The coefficient always goes in front of the variable. We have a times 3 plus a times negative 2a. Now this gives us 3a minus 2a squared. You can't leave it like this. We must remember to put it in standard form. Standard form means alphabetical order, and if we have the same variable, which we do in this case, it's the variable with the largest exponent. So negative 2a squared is going to come before 3a to the first. It's not the coefficient, it's the variable and its exponents that determine the order. Negative 2b times negative 4b. Negative 2b times 3, we're going to multiply the constants and then the variables. We're going to multiply the constants and then the variables. We have to put it in standard form. 8b squared minus 6b is the final answer. That is simplified. You can't leave it not in standard form. You must change the values. So we have negative 3c times 4c minus 3c times 1. Negative 3c times 4c is negative 12c squared. Negative 3c times 1 is negative 3c. We can't combine these two. Even though they have the same variables, they are unlike terms because like terms have the same variable to the same exponent. 5y times y plus 5y times 6. 5y times y is 5y squared. 5y times 6 is 30y. Negative z times 4 minus z times negative 5z. Negative z times 4 is negative 4z. There's an invisible coefficient of negative 1. times 4 is negative 4, and then the variable. And we have negative 1z times negative 5, and z times z, which gives us positive 5z squared. Let's write it in standard form. All right, now we have 3 terms. So nothing different. You're just going to distribute it instead of 2 terms, 3 terms. This is a trinomial, so we will distribute it 3 times. We have 3x times x squared plus 3x times negative x plus 3x times negative 2. We are distributing that 3x. We see the 3x that is being distributed to each of the terms. That's the first term. This is the second term. And this is the third term. So make sure that you distribute it to each of those. Now we're going to multiply each of these, because we're going to do multiplication before the addition and subtraction. So 3x times x squared is 3x to the third. 3x times negative x is negative 3x squared. 3x times negative 2 is negative 6x. We can't combine these. We can't do the addition and subtraction because they are unlike terms. So that is simplified. Negative 2x times x squared minus 2x times negative 4x, negative 2x, times 5. Negative 2x times x squared is negative 2x to the third. Negative 2x times negative 4x is positive 8x squared. And negative 2x times 5 is negative 10x. Constants, and then, or coefficients, and then variables. Negative 4x times 2x squared minus 4x times negative 3x, negative 4x times negative 7. That gives us negative 8x to the third, positive 12x squared, positive 28x. You do enough of these, it becomes rote, meaning we can just go through and see the pattern in the similarities between these. 5x squared times x squared is 5x to the fourth. 5x squared times x is 5x to the third. 5x squared times negative 3 is negative 15x squared. Negative 6x squared times x squared minus 6x squared times negative x minus 6x squared times negative 12. That's negative 6x to the fourth, positive 6x to the third, positive 72x squared. Know our times tables. 4x to the third times x squared plus 4x to the third times negative 3x plus 4x to the third times negative 6. 4x to the fifth minus 12x to the fourth. Remember, when we multiply like bases, x to the third times x to the second, we add their exponents. Hence why x to the third times x to the second equals x to the fifth. And that's minus 24x to the third. Now we're going to distribute this to each of the terms. I'm going to write it. I'm going to take the time to rewrite each of the products. I don't know if that's how they want you to do it, whether they just want you to multiply and then put the answer down there. We'll try it this way to start. I'll do it the other way. 6a to the third minus 8a squared minus 12a. I like writing my steps down because I like to see it, but 5a times 4a squared is 20a to the third. 5a times negative 5a gives us negative 25a squared. 5a times negative 7 is negative 35a. I don't feel as comfortable with that. That's more too abstract. I like seeing it. I like seeing the process separated out, but I'm a writer. 10x to the fourth minus 2x to the third minus 6x squared. I like having concrete stuff that I can see with my eyeballs, because it does get a little confusing with all the negatives and positives and distributive and variables, and it makes it a little bit easier for me to see now the coefficients and the exponents, how I can see the coefficients multiplying and then the variables, and I can see the coefficients and I can see that there's only a variable there. Same thing, now we have two variables distributed, and we've got two variables there. We have one variable here, so we just want to, again, write it out. 4x squared plus 3x squared y times negative 5xy plus 3x squared y times negative 2y squared. So I'm going to multiply. The 3 times 4 is 12. The x squared times x squared is x to the fourth. And then I have the y hanging out left over. I'm going to multiply the 3 times negative 5, which is negative 15. I'm going to do the x squared times x is x to the third. I'm going to do the y times the y, which is y squared. I'm going to do the 3 times the negative 2 is negative 6. The x squared doesn't have a partner. The y times the y squared is y to the third. Now the question is that in standard form? Well, first of all, can I combine any of them? No, none of them have the same variable to the same exponent in any of them. And is it in standard form? Yes, it is. I look at my first variable in each of the terms, and it's got to be alphabetical order. We notice that they're all x's, so I can't differentiate which one comes first by just the variable. They all have the same first variable. Then I look at the exponent, x to the fourth, x to the third, x to the second. It needs to be in descending order. So x to the fourth comes first, x to the third, x to the second. So this is correct. This is done correctly. That is standard form. That is my answer. I can't combine them. I don't have to rewrite them. xy squared times x squared plus xy squared times negative 4xy plus xy squared times negative 5y squared. X to the third y squared, negative 4x squared y to the third, minus 5xy to the fourth. That's how fast and easy this can be done. As long as you write it out and you are well versed in your products of monomials, because that's all we're doing. We eventually are just multiplying monomials times monomials. And did you take the time to master it when we did it earlier? That's negative 8x to the third y. This is positive 6x squared y, and this is negative 2xy to the third, all in standard form. Ooh, fraction squared 6x squared plus 1/3 x squared y times negative 12xy plus 1/3 x squared y times 9y squared. So we're going to multiply coefficients. 1/3 times 6 is 2. You should be able to mental math that. X to the fourth y. 1/3 times negative 12 is negative 4. You should be able to mental math that. X to the third y squared. 1/3 times 9 is positive 3. You should be able to mental math that. X squared y cubed. Should not slow you down. 2xy squared times 3x squared plus 2xy squared times negative 7xy plus 2xy squared times negative 2y squared. 6x to the third y squared minus 14x squared y to the third minus 4xy to the fourth. Also in standard form. Negative 4x to the third y times x squared minus 4x to the third y times negative 3xy. Negative 4x to the third y times negative 6y squared. Negative 4x to the fifth y plus 12x to the fourth y squared plus 24x to the third y to the third. Making sure I did that correctly. Yep. Descending order. We're good. 5xy times 2x squared plus 5xy times negative 4xy plus 5xy times y squared. At this point, we have done 5 or 6 of these, and we're just going through. Can you do it just as fast, just as accurate, and just as efficient? 10x to the third y minus 20x squared y squared plus 5xy to the third. This y to the third does not go first because my first variable in that term is x. It is always determined by the first variable in the term. 1/2 x squared y squared times 6x squared plus 1/2 x squared y squared times negative 4xy plus 1/2 x squared y squared times negative 8y squared. 1/2 times 6 is 3. X to the fourth y squared. 1/2 times negative 4 is negative 2. X to the third y to the third. 1/2 times negative 8 is negative 4. X squared y to the fourth. All right, now we are going to distribute twice. We have 2 different distributions, and after we distribute, we will notice that we might have like terms. So we're going to have to simplify after distributing. So we will distribute, we will do that product, do those products, and then we will see if there's any like terms. Oh yeah. So 2x times x plus 2x times negative 3. That's distributing these. And then we have to distribute the 3x. So that's plus 3x times x and plus 3x times 2. We're distributing the other term into the binomial. That gives us 2x squared negative 6x. That gives us 3x squared and plus 6x. So we have like terms. Like terms have the same variable to the same exponent. Like terms have the same variable to the same exponent. So we have 2x squared plus 3x squared minus 6x plus 6x. When we have like terms, we're going to combine their coefficients. 2 and 3 makes 5x squared. Negative 6 and positive 6 cancel to make 0. So you're just left with 5x squared. 4x times 3 plus 4x times negative 2x plus 5x times x plus 5x times negative 1. 12x minus 8x squared plus 5x squared minus 5x. Let's put them in standard form. I'm going to put them in order, and doing so shows where the like terms are. That's negative 3x squared. That is going to be plus 7x. 5x squared times 2x plus 5x squared times negative 1 minus 2x times 3x squared minus 2x times negative 4x. This is going to give us 10x to the third minus 5x squared minus 6x to the third plus 8x squared. Let's put them in descending order. Let's combine like terms. That's 4x to the third by their coefficients. And this is plus 3x. Woo! Did I do it? Oh, I forgot the square there. See, I looked and I was like, oh, so you had to check. Make sure, don't go so fast that you make a silly mistake. So I was able to catch my mistake because I had written my work down. Very important to write your work. If you don't write your work, it's going to be very difficult for you to find your errors. That's 12y cubed minus 9y squared minus 2y cubed minus 2y squared. Descending order. And now let's combine like terms. That gives me 10y to the third. This gives me negative 11y squared. 2n squared times 4n plus 2n squared times negative 5 minus 3n times 2n squared minus 3n times negative 7n. 8n to the third minus 10n squared minus 6n to the third plus 21n squared. 8n to the third minus 6n to the third minus 10n squared plus 21n squared. 2n to the third plus 11n squared. 2x, now we're getting into the mastery part. We're doing so many that we're becoming proficient. We're becoming fluent that we can do this almost with our eyes closed. 10x to the third minus 6x squared minus x cubed minus 6x squared. Look how fast we can do this. Let's make sure that we can do it with speed and accuracy. That gives us 9x to the third minus 12x squared. Boom! Can we do the problems under? All right, now we're solving. So we want to simplify. Always simplify the left side before moving things. So we're going to distribute. And we can have 2 times x plus 2 times negative 1 plus 3 equals 7. That gives us 2x minus 2 plus 3 equals 7. 2x plus 1 equals 7. I have simplified the left side. And now this is a two-step problem. We're going to get rid of things being added and subtracted first. Then we will divide, and we get x equals 3. We can check our answer. Let's check if x equals 3. We're going to take that starting problem, copy, and we're going to paste it right here, and we're going to check it by plugging in that value. So 2, we're going to put a 3 in for x, and we're going to simplify the left side again. We're going to do inside the parentheses. We're not moving things left and right. We're simplifying the left side. Does the left side simplify to the right side? That's 4 plus 3. We're going to do multiplication before addition and adding, and yes, that means x does work. Okay? Here's another way that we can do this. So I'm going to show you a, not copy page, clone page. I'm going to show you a technique that students in high school might do. This is an efficient way. I'm going to subtract 3. I want to get to that variable, so I'm going to get rid of the things outside of it. I have something multiplying. Chewbacca's here, so I can't get into the x because Chewbacca's there. We haven't heard Chewbacca in a while. Oh, that was a long one. So 2 is multiplying, 3 is being added, so we're going to get rid of things being added and subtracted. And we get this, and then we're going to get rid of the multiplication outside. And when we get rid of it, Chewbacca goes home. And then we add 1, and we get x equals 3. Same solution. We were able to do it without distributing. So That is a very complex, a very advanced, a very high school way of doing it. I would suggest that you move towards that, but because this section is dealing with distribution, we are going to continue to distribute in order to isolate to get to the variable. So even though I wouldn't do this typically, if I had to do this problem on a test, I'm going to do it in this fashion because we want to practice the distributive property. And now we're going to simplify the left side. Now it's a two-step problem. Now we're going to move the -5, and now we're going to divide by 3, and we get y equals 5. Okay? Ooh, double distribution. So in this case, we wouldn't have been able to use that high school technique because we got two different, well actually there's another way we can do this, but it's all right. We're going to show the distributive property. So that's 2 times 2m plus 2 times -3. We're going to distribute out the -3 times the 2m, and the -3 times the -1 equals 9. That's 4m minus 6 minus 6m plus 3 equals 9. Let's simplify like terms. So that's -2m minus 3 equals 9. Now it's a two-step problem. We're going to move the things being added and subtracted. We're going to divide by 2, and we get m equals -6. Don't forget that negative. That's a tricky one, okay? Yeah, there's a very interesting advanced way to do this problem. For any of you that want to see a very sophisticated, let's clear the ink. We know, oh no we don't, sorry. Mark, forget that. There is no sophisticated way other than distributing. That's the right way, sorry. I got ahead of myself. So we'll distribute 4 times 3a plus 4 times -1 minus 5 times 1, -5 times -a equals 8. 12a minus 4 minus 5 plus 5a, like terms, like terms. That's going to give us 17a minus 9 equals 8. Add 9 to both sides. We get 17a equals 17. We're going to divide by 17, and we get a equals 1. Yep, that fast. Distribute the y, distribute the 2. We get y times 3 plus y times -2y plus 2 times y squared plus 2 times -6 equals 0. 3y minus 2y squared plus 2y squared minus 12 equals 0. These are the only like terms, and they're going to cancel, which leaves me with 3y minus 12 equals 0. We're going to add 12 to both sides. 3y equals 12. Divide by 3, y equals 4. Distribute. Now everything is on the right side. It doesn't change anything just because your variable's on the right side. We still are going to distribute the two terms into the parentheses. We're still going to simplify. We just simplify the right side. Minus 6x minus 15 plus 5x. We have like terms here. We have like terms here. That's going to give me 0 equals -x minus 12. We could move the constant. I'm going to move the x because it's negative, and moving across changes its sign, and we get x equals -12. I did that efficiently. That's a much more efficient way to do that problem instead of moving the -12 and then getting rid of the negative in front of the x. So x times 2 plus x times -3x plus 3 times x squared plus 3 times negative 6 equals 0. 2x minus 3x squared plus 3x squared minus 18, that's a horrible 18, equals 0. These are like terms, they cancel. 2x minus 18 equals 0. Add 18. 2x equals 18, divide by 2. X equals 9. I think that was the last one. Nope. Still more, which is okay, because it just makes us better. The more problems we practice, the better we become. Don't feel that more is bad, more is better. 2x minus 6x squared plus 6x squared minus 12 equals 0. These are like terms, they cancel. 2x minus 12 equals 0. Add 12. 2x equals 12. Divide by 2. X equals 6. That was the last one. All right. It's a long video, but excellent practice. Lots of good skills practice there to make you a better solving for the variable. Love that. Multiplying, really important. Good luck.